Okay, we're at the momentum review. So we've got speed is distance divided by time. We've got acceleration is change in velocity over time. We've got the net force. Remember, it has to be the net is the mass times the acceleration. And now we're moving on to this formula, which is momentum. P for momentum, right? For your mom and Tom. Is the mass times the velocity, okay? So this is what we're looking at. The triangle for this one, if you like the triangle method, is that P on top is M times V. It's a lot like F net equals MA. We're just measuring momentum now. So a couple simple questions. Determine the momentum of the following. Well, actually, I like to start here. What is the unit types that we're using? Kilograms. Okay, hopefully you're getting used to it. 6.3 doesn't tell us much, but kilograms tells us that this is a mass. Now we got 878, doesn't tell us much, but it's kilogram. Wait a minute, so it looks like a mass, but it's also meters, and then divided by seconds. This is a weird one, right? Kilogram meter per second. This is a momentum. Oh wait, M is not momentum, P is momentum. And so 878 kilogram meters per second is P for momentum. You see N, capital N, this means newtons. So this is measuring, and capital F, a force. Now the lowercase m is meters, okay? Meters is a distance. So this is measuring a distance. S for seconds is measuring a time, 415 seconds. 212 meters per second, m per s. A distance divided by a time. This means this is measuring a velocity. And here we've got almost the same thing, but it's meters per second squared. So it's meters per second. So this is an acceleration, all right? A change in time over time, a change in speed over time. And last one, we got 15 centimeters per minute, a distance, right, divided by a time gives us neither distance or time, but rather a speed. This is your distance is changing over time, so this is a velocity. All right, so we've got our units down packed, and now we can do a good job of doing our questions. A 30 kilogram, this is the mass of the dog that is running at 11 meters per second. That's its speed. We're going to use P equals mv. And so to do that, we do P equals, and our mass is 30 times our velocity, times our velocity of 11 meters per second, and we get 30 times 11 is 330 meters per, what are units? We already did this, kilogram meters per second. Kilograms, meters per second. 30 is kilograms, and 11 is meters per second, and so you add them up and you get kilogram meters per second. Okay, so there we go. A cat is running at 2.1 meters per second. There's our velocity, and has a mass of 4.1 kilograms. There's the mass. You can tell by the units. And so, once again, P equals our mass, which is 4.1 kilograms, times our velocity, which is 2.1 meters per second. Gives us an answer of 4.1 times 2.1, and that's 8.61 kilogram meters per second. That messed up unit is our momentum unit. And so now we're going to move to another type of question. Okay, and this type of question, I'll encourage you again. If you think you know how to do a question before I do it, quickly pause the video. Pause it, try it. So don't let me rush and run right over you. Just pause the video when you need, try the question, and then see if you did it right. Watch my explanation. Okay, what is a combined momentum of a 3 kilogram box that's moving 2 meters per second north and a 4 kilogram box which is moving 1 meter per second north? They're both moving the same direction. They're both moving north, which means if they would both hit you, it would move you more than if they would hit you moving opposite directions. And so together their momentum is in the same direction, and that's important. This is a lot like forces, okay? A lot like forces. If they're in the same direction, we got to add them up. All right, so what do we got here? We've got box 1, okay, and it's got mass 1 and velocity 1. And then we've got a box 2, which has a mass 2. That means I'm just distinguishing because 4 kilograms is not the first box, and it's got a velocity 2. Now we have to keep them separate for the first bit, okay? And so the way we do that is I do P underscore 1, subscript 1. And so the first momentum is the first mass times the first velocity, because P equals mv. And so I'm going to do 3 times 2. And that gives me 6 kilogram meters per second. Okay? And in the direction north. And now P2, so the momentum of the second box, is the mass of the second box, which is 4, times the velocity of the second box, which is 1. And that gives me 4 kilogram meters per second. Okay? And so now we've got 6. Oh, and what direction was this? Also north, right? Its velocity is north, so its momentum is north. Since they're the same direction, they're going to add together. And so our total, so I'm going to do P underscore total, is going to equal 6 plus 4, because they're in the same direction, which is 10 kilogram meters per second north. There we go. And so this is our final answer. Ran out of room here. I'll draw a circle around it. Here's our final answer, 10 kilogram meters per second north. So if we have multiple moving objects, their total momentum is it added together if they're in the same direction. And they're going to be subtracted if they're moving in opposite direction. So pause the video and try this question. These are opposite directions, so they're going to have to be subtracted. So pay attention to that. Try it out. All right, I will do this. A 70 kilogram biker. This is the mass 1, because I can anticipate we've got two different moving objects, and we've got our velocity 1, which is east. Now we've got a 90 kilogram runner, which is mass 2, the second object, and the velocity of the second object. Okay, and so we just got to keep those separate. So P1 is the mass, which is 70, times the velocity, which is 10, and that gives us 700 kilogram meters per second in the direction of east. Okay. We've got momentum number 2, which is the mass number 2, which is 90, times the times the velocity of the second object, which is 3 meters per second, and that gives us a total of 270 kilogram meters per second in the direction west. And so what is our total momentum? We've got momentum 1 of 700, momentum 2 of 270, and they're opposite directions, which means we're going to have to subtract them. So P total equals 700 minus 270, and that gives us a final answer of 430. Is that right? Yeah, that looks good to me. Kilogram meters per second in the direction of, which one is bigger? East. Okay, so we took the two, we added them together, and our final answer is this. East was bigger. It was the 700 was east, and so our final answer has to be east. So there we go. If we have multiple moving objects, we have to take the sum of them. If they're in the same direction, we add them together, like the first 2A, and if they're in opposite directions, we subtract them, like 2B. This will get you going on a lot of tough momentum questions if you can get this straight. So we have taken momentum, we can identify it, and then if there's multiple moving objects, their momentums have to add together. Positively if they're in the same direction, and the adding together cancels out when they're in opposite directions. So let's follow the next word problems. A golf ball is moving at 39 meters per second. Once again, try these if you feel comfortable. Try them and then pause the video once to try them, and then play it again to see how you did. So 39 meters per second, this is a velocity, and it has a momentum here. So this is its P value of 1.794 kilogram meters per second. What must be the mass of the golf ball? We've got, oh, I should draw my triangle. Triangle looks like this. P equals mv. And so we want to know what the mass of the golf ball is. So we're going to say m equals, and it's P over V. So we got to keep it that way, P divided by V. And so if we plug in what we know, we've got m equals our momentum of 1.794 divided by, our velocity, which is 39. And it gives us an answer of 1.794 divided by 39 is 0.046 kilograms. It's almost like that's the real mass of a golf ball, because it was the same here as it was in the force problem. That's neat. Someone really did their homework when they put this together. Try the next question. It's got two momentums, two objects. All right, for this one, we've got a 30 kilogram box and a 20 kilogram box. So there's two of them. So we're going to call this is a mass. This is mass 1. I'm going to call this mass 2. All right. And the first box has a velocity of 2 meters per second. So that's velocity 1. And the second box has a velocity, so V2, of 4 meters per second. Notice that this one's to the east and this is to the west, so they're going to cancel out. All right. So what we've got is, that's the first thing we should do. We're going to be wondering what our final velocity is, because they're going to stick together after the collision. But let's do that later, okay? Let's first just find what the total momentum is, kind of like we did up top. And so what I'm going to do is P1 is mass, which is 30, times velocity, which is 2, and that gives me 60 kilogram meters per second. P2 is 20 kilograms times the velocity, because P equals mv, of 4 meters per second. And so that gives us 80 kilogram meters per second. And now we look, which is bigger, because this one, let's not forget, is, what is this one? This is east. P1 was east, and P2 was west, so they're opposite directions. So we're subtracting them. And so we do P total equals, in this case, 80 minus 60, which is 20 kilogram meters per second, towards the bigger one was west. Okay, so you got to look here. This bigger one was west, and so that's what we have to apply here. Okay, so we've got our total momentum. Now here's the rule of conservation of momentum. Is the momentum, this is the total momentum going in. This has to be the total momentum after the collision as well. But after the collision, their masses, they stick together. And so after the collision, what I'm going to do is I'm going to just clear some of this drawing up. Oh no. All right, so let's try this. This is our total. This is what ties the two together, okay? This is our total. And so what I'm going to do is I'm going to say this is before the collision, and this is after collision. Great writing. Thank you. Okay, and so before the collision, after the collision. After the collision, notice that this total is tying them both together. Before we've got a total of 20, and after we've got a total of 20 kilogram meters per second. West, right? And so what we are going to do is we're going to figure out what their mass is after the collision. So after the collision, the mass total is 30 plus 20, and that gives us a total of 50 kilograms. And so if their total mass is 50 kilograms and their momentum is 20 kilogram meters per second, then we could figure out, well, what are we actually looking for now? We're looking for the velocity, the final velocity, and so we need to know the momentum divided by mass. And so V final, F for final, is going to be the momentum final divided by the mass final. Okay, so this is the final momentum, this is the final mass. I could be writing total, but give me a break. I'm not writing that with my hand. And so what I'm going to do is the F equals, we've got 20 kilogram meters per second divided by, what was our total mass? 50 kilograms. And so we did our P divided by P divided by M, and we get 20 over 50 is 0.4. Do an equal sign there, equals 0.4 meters per second in the direction west, same as the final momentum. So together they're going to collide, hit, and move west at 0.4 meters per second. Awesome. So that's pretty cool that we can take two boxes that are moving opposite directions, different speeds, and figure out exactly how fast together they are going to move. That's neat. That's pretty cool to be able to do that. And so our last question, a rifle. This is cool. This is about recoil, right? Kickback from a gun. And so a rifle has a mass of 4.5 kilograms. Okay, so there we've got the mass. And it fires a bullet. Here's the mass of the bullet. So mass 1 is the gun. Mass 2 is the bullet of 0.009 kilograms at a speed of 802 meters per second north. This is the speed of the bullet. Okay, so we've got the two pieces of the bullet. If the gun is not held, what would be the velocity of the gun after firing? So the idea here is before firing, what's the speed? VI for V initial. The initial speed is 0, which means the initial momentum is 0. Okay, the total momentum at the beginning is 0 because nothing's moving. And then you fire. Now there's a moving bullet moving one way, right? Little bullet. And there's this long gun that fired the bullet. That's a great gun. That is now going to be moving that way. But it's a lot heavier, so it's going to move backwards a lot less fast, right? We've got two moving objects, but the momentum has to stay balanced at 0. And so what we've got to notice is, what is the momentum here? The momentum forward has to equal the momentum that goes backwards, and they have to cancel out to get back to 0, because that's our total momentum. That's important. So it's important to understand that if something's stationary at the beginning, the total momentum is 0. And so what we're going to do is we are going to find out what is the momentum forward and apply that to the gun moving backwards. And so I'll do this here. The momentum P of the gun, of the bullet, is equal to the mass of the bullet, which is 0.009, times the speed of the bullet, which is 820 meters per second. And that gives us 0.009 times 820, 7.38 kilogram meters per second. Forward, north in this case. And if that's the case, then that is also the momentum of the gun. Because they have to match, because they started at 0, and so they have to exactly cancel each other out. That's the rule of conservation of momentum. So 7.38 kilogram meters per second is the momentum of the gun as well. Okay, I could draw these little therefore dots. Therefore, the momentum of the gun is also the same thing. And since we know the mass of the gun, then we're going to look for the velocity. So same, it's going to be velocity is momentum divided by mass. And so the velocity of the gun equals the momentum of the gun divided by the mass of the gun. That's what we're going for. We have to keep it all consistent. And so what we get is the velocity of the gun equals the momentum of the gun is 7.38 kilogram meters per second squared divided by the mass of the gun, which is 4.5 meters per second squared. And we get an answer of 7.38 divided by 4.5, 1.64 meters per second. So I think that's in meters per second. This is kilograms, clearly kilograms here. Okay, I'm taking that number from here. That's the mass of the gun. And so this is our final answer. We took the momentum of the bullet, applied it to the gun, because they have to equal, because they started off at 0, they weren't moving, so they have to balance out. So the gun is moving backwards at 1.6 meters per second, which is actually pretty fast. Think of a gun moving 1 meter in a second. This is like almost 2 meters in a second. It's pretty cool. While the bullet is moving way faster, but it's much smaller. So this is how these momentums equal each other out. So the advice I give after each worksheet is go find momentum practice questions in the reviews that I've given you. Practice questions like this. If you have more questions, please feel free to ask, but hopefully this has helped you gain some confidence. That's the goal. All right.